This is CPSG 101, Science and Global Change, first year colloquium 2, Impacts of Climate Change Project. And our topic is the West Antarctic Ice Sheet Stability. It's going to be done by me, Nicholas Kalbaugh, Arnav Kulkarni, and Rahulreddy Pinninti. So first is the introduction to the West Antarctic Ice Sheet. So what is the West Antarctic Ice Sheet? As you can see on the right, two arrows are pointing to two parts of the Antarctic ice sheet, like the whole Antarctic ice sheet, and you can see the transantarctic mountains and an ice shelf. So these two regions, everything to the west of these regions is labeled as a West Antarctica. It's an area of almost 2 million kilometers squared. It reaches depths of over 2,000 meters. And along with the East Antarctic ice sheet, it contains up to 70% of Earth's fresh water. So here are our issues and effects with West Antarctic ice sheet instability.
So what is currently happening? So two significant issues that are happening due to global warming are the thinning of ice and ice sheets melting. Due to the increase in the temperature from global warming, the water also becomes warmer than what is sustainable for ice. So because the water becomes warmer, the ice starts to thin and the ice sheets completely melt. And this leads to an increase in sea levels. And as you can see on the graphic on the right, the teal blue and sky blue colors around the Ron ice shelf, which is northwest. Uh, that shows that the ice sheets are melting because as the ice is going underwater, and you can see by the color that the height is less than 0 feet. What may or will happen in the future? One significant thing that will happen is global flooding. So, like I said before, the ice sheet melting will result in a higher sea level. And once the West Antarctic ice sheet melts, it will also make the entire Antarctic ice sheet melt faster. And if the entire thing were to collapse, the sea level could rise a total of 3 meters, and this would lead to global flooding in coastal areas around the world. And you can see on the graph on the right, the moderate RCP, which is 4.5 on the graph, you can see that even so the projected rise in sea level is around 8 centimeters. But however, if global warming increases and continues to significantly impact the world, the RCP at 8.5 tells us that the sea level could rise 12.5 centimeters per decade. And the second significant issue is just major economic loss and like the cost of repairing the damage due to the flooding from the West Antarctic ice sheet is very expensive because the machinery, electricity, and manpower that is required to pump and circulate water is not cheap. It takes a lot of money to have those resources. And additionally, the flooding caused by the melting of the ice results in massive losses in land and just buildings just being destroyed and a lot of homes being destroyed. And it will take a lot of money to make up for that damage, especially the land. And finally, there may be a need for seawalls to be built to just prevent the rise of the sea level um, and prevent the impact that the rise in sea level may have towards the land.
So part 3 is the absolute collapse of the Antarctic ice sheet, which could possibly happen in the future, especially as the West Antarctic ice sheet melts. It rapidly causes the entire Arctic ice sheet to melt. This would lead to complete loss of the Antarctic ecosystem and an unparalleled climate disaster affecting weather, ocean circulation, and things all around the world. So who and what does this affect? So in a way, this affects every single inhabitant of our planet because of the way it will change the climate, um, the way land is distributed, and the economy. But it'll also specifically affect 50 to 100 million people that live in coastal areas due to displacement. This will be due to the fact that the ocean waters will become much higher in height. And it'll also lead to many countries not being able to afford the cost of the damages, which will lead to entire small countries possibly disappearing in the future. And of course, it'll affect habitats for countless animals.
Now we're going to focus on the why of the destabilization of the Antarctic ice sheets. So why are the West Antarctic ice sheets destabilizing? From our research, we were able to come up with 4 prominent reasons. First 2 reasons being the warm water incursions and the increased rates of ice flows. The warm water incursions from the Pacific Ocean into the Antarctic water regions is caused by the changes in the Antarctic coastal winds that are accelerated due to anthropogenic heating, which bring in warm water from the Pacific Ocean oceanic regions into the Antarctic oceanic regions. The increased water temperature causes the ice to melt at a faster rate, thus destabilizing the overall West Antarctic ice sheet region. The second reason, of course, being the increased rate of ice flows near the West Antarctic ice sheets. The graphic to the right depicts that accurately, as the ice tail is thinning due to the warm water coming into the region, which is increasing the natural rate of ice flow to a much more higher rate than before, which of course is chipping away at the amount of ice sheet area in the West Antarctic region. The other two prominent reasons that we found were the higher downward radiation and reduced albedo and the increased hydrofracturing of the West Antarctic ice sheets. Of the two, the first one being the higher downward radiation, which is caused by increased amounts of humidity near the Antarctic regions, and the reduced albedo, which is due to the accelerated melting. The accelerated melting is occurring due to the fact of anthropogenic heating and global warming. So albedo works when there is a higher amount of ice and snow in the area, which allows a higher amount of the sunlight radiation to be reflected away from the surface. As you can see, 85% of the radiation and the sunlight is being reflected, but as there is a lesser and lesser area of ice and snow, the amount reflected decreases, thus increasing the amount that is being absorbed, which will, of course, heat up the surrounding areas. And the last of the 4 reasons that we found to be prominent were the increased hydrofracturing. This plays in tandem with the first reason, being that the accelerated melting causes increased more rainfall and subsequent net production of surface liquid water, which causes ponding or pooling of water. So ice naturally forms with cracks in its base, but when these cracks are filled with water and the water begins to burrow down deeper into the cracks, it causes fractures, thus the name hydrofracturing, which chips the ice sheets into smaller and smaller pieces, which allows for quicker melting and destabilizing the ice sheets as a whole. So now we're looking at the conservation part of the project, being what can we do to mitigate the damages that are done to the West Antarctic ice sheet regions. From our research, we came up with 2 viable solutions. One viable solution being that we pile vast amounts of snow onto the top of the melting ice shelves, slowing down the ice shelf melting and collapse, which this process would require, again, a water pump of tremendous size that dispenses cold water throughout the region, which then is sucked up into a pump, frozen, and then is spewed out in the form of snow, thus regenerating the ice sheets. The second viable solution, of course, being, again, using the same cold water pump, but this time to dispel warm water away from the region, which we discovered in the previous regions in the Y of warm water coming in. While the warm water is coming in, it'll also be pumped out by the cold water, thus cooling down the regions. And when it's being cooling down, it'll allow for the ice sheets to regenerate themselves and slow down the destabilization of the ice sheets. This is our bibliography, and thank you for watching our presentation.